Assalamualaikum and hi to my students. This video is about Cartesian product. Cartesian product is one of the operation between sets. Based on the definition, Cartesian product, suppose we have two sets. Imagine we have A, 1, 2, 3, and we have another set, B. Let me take 7 and 9. We have two sides right now. Cartesian product is given by this symbol of times, A times B. If we have two sets, so we call it as two tuple, and we have an ordered pairs as the outcome. A times B, let's settle for the first ordered pairs first, 1 and also 7. Notice that we take one element from A and we take one element from B to be paired as an ordered pairs. We finish them off, 1, 9. We have 2, 7, 2, 9, 3, 7, and 3, 9. Just now I mentioned about the word ordered pairs. Although the definition of set, it might not necessarily the elements inside the set must be in order. But in this case of Cartesian product, the order comes here. This one. Notice that A times B, the first element comes from A and the second one comes from B. Same goes for the other element of the ordered pairs. The order inside the bracket cannot be interchanged. We go back, for example, in this B times A. In this time, the first element on the left here should comes from B, 7. You pair it with 1, you pair it with all possible elements from A as well. Finish with 9, 1, 9, 2, 9, 3. As this A and B, these two sets have different elements inside. Therefore, A times B, as you observe, is not equivalent with the element of B times A. Using the same set of A, try to do A times A. The operation on the same set, A times A, 1, 2, and 3. You will have 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. You finish it off with 3, 1, 3, 2, and also 3, 3. It's that simple. Can you do this for B times B as well? Let us take this example B, 7, 9. And we do a Cartesian product of B times B. And suppose you already do the answer, it will be 7, 7, 7, 9. 9, 7, 9, oh no space, 9, 9, I put it down. Now comes the question, how do you ensure that you have enough ordered pairs inside the operation? We use this formula, the general one, is given as the cardinality of A times B should be equivalent with the cardinality of A times the cardinality of B. Right now we focus here. We have B times B. How many ordered pairs should be there? Okay, I repeat, how many distinct ordered pairs that should be inside? So if you use this formula, what is the cardinality of B? And as you recall from the previous lecture, the cardinality of a set is given by the number of distinct elements inside the set. So the cardinality of B is 2 because you have one element, two element, 2. The cardinality of B times B will be cardinality of B separately times B will be 2 times 2. You should have 4 distinct is different, ordered, non-repeatable ordered pairs. Let us do some different example on the next page. Example 1. Let A equals to 1, 2, 3. And B is given as X, Y, an alphabet. It doesn't matter. The answer has already been provided there, A times B and also B times A. Please verify it back on your own because the answer, the solution is already there. My question for you right now, what is A times A? And you will do the solution on your own. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 2. What's wrong here? Do I have enough distinct ordered pairs? Right now, if you count my cardinality here, A times A here, and you give the answer, it should be 9 because the cardinality of A is 3 times A. You said it will be 3 times 3, it should be 9. The problem with this solution is that although you count it, it has 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You must be careful here to not write the same ordered pair twice. In this case, I wrote 3, 2 times. So right now, I only have actually 8 ordered pairs. Although inside the previous solution, I write 9 ordered pairs. So please be careful. This is a common mistake by my students. The thing that is left is actually 3. Right now you have clearly 9 distinct ordered pairs. Then your answer will be correct. Next we proceed to the example which involve 3 sets. If you involve Cartesian product between 3 sets, now it's known as ordered triplets or 3 tuple. The solution given here, A equals to, A equals to 1, 2. This is the question, I just write it back, X, Y, and C is given only by one element, which is the infinity symbol. The solution given in the slide is A times B times C, and yes, that's the answer. You should have 4 distinct ordered triplets because 2 times 2 times 1 is equivalent to 4. Can you do B times A times C? please ensure that your ordered triplets must start with the element from B first. Let's take X. The second element should comes from A, and the last one should comes from C. We have finished the first order triplets. We proceed with the next one, y1 infinity. I take x to infinity and y to infinity. And I still should have 4 ordered triplets because the cardinality of B is 2 times the cardinality of A is 2 times the cardinality of C is 1. So 2 times 2 times 1, it still be 4 ordered triplets. But as you can observe, the difference between the answer from the example 2 beside is that you must ensure this comes from B, this comes from A, and this one comes from C. And please do make sure that you don't have duplicates of ordered triplets. If you do that, if you check that, then you should be fine. That concludes the lecture of Cartesian product.